So after I've released the Tech Interview Pro course, I got a lot of questions regarding the tech interviews Google does, Facebook does, and so on. And who's better to ask than the tech lead? In his CoderPro course, he shows you exactly everything about the popular coding interview questions at those top tech companies like Google, Facebook, Apple, Amazon, and Microsoft. We will take a look inside. I will show you exactly what awaits you inside. Like you already see here, you will get a collection of 100 plus video explanations of popular coding interview problems, and those are explained by TechLead that did those interviews himself. If you're applying or if you're planning to apply to one of those top tier tech companies you see here, then definitely get the course. You will learn exactly from an interviewer how to pass those tests. Let's go and let's take a look inside. Before we start, you can get the CoderPro course via the link under the video. Just click the link, watch the video of TechLead where he explains you how to get inside those top tech companies and even gives you the first example. Just check it out via the first link in the video description. When you get the course via this link, then you will also get my automation mastery worth $497, where I show you exactly how to automate most of your recurring processes, whatever you do online, by using the right tools and strategies that can definitely additionally help you in your workflow working at those companies. I will give it to you completely for free in my Bonusbomber package. Just get CoderPro via the link under the video, bonusbomber.com/CoderPro, like you already see here. Let's start and let's take a look inside. Alright, here we are inside the members area, and like you already see here, TechLead welcomes you here to the course, to CoderPro, where he explains you everything in regards to the interview process. We will take a look at the first video in the course. I will show you what awaits you here and what TechLead teaches you here. First video is valid binary search tree, so let's not waste time and let's take a look inside. Let's go.
Hi, TechLead here and welcome to CoderPro. So as an ex-Google, ex-Facebook tech lead, I've had the opportunity to conduct over 100 interviews over at Google, Facebook, and across the software engineering industry. So if you too are preparing for the technical interviews, then with CoderPro, I'll be teaching you all of the coding, data structures, and algorithms you need to know to ace the whiteboarding portion of your interviews. Let's get into it. The first question is known as valid binary search tree. Alright, so let me show you how this works. But you're given a binary search tree and there's going to be some numbers in there, like for example 5, 4, and 7. And our job is to check whether this is a valid binary search tree. And if you recall, a binary search tree maintains the property that all nodes to the left are less than the value and all nodes to the right are greater than. And so for example, for this case, we would say, well, yes, that is a binary search tree because 4 is less than 5, which is less than 7. However, if I made another binary search tree that looked like 5, 7, and 4, well, this would not be a valid binary search tree, so we'll say that's not valid. And furthermore, there's also another interesting example I can show you that's not going to work. So we have 5, 4, 7, and then there's a 2 here. And so in this scenario, even though the node at 2 is less than the node at 7, so the binary search property holds, 2 is still greater than the top node at 5, right? So that makes this an invalid binary search tree because all nodes to the right of 5 are not greater than that in value, right? There was a 2 there. And so that's the question, and your job is to write a function to validate a binary search tree. This is exactly the type of problem that you would be asked in a real programming interview, so I'll give you a moment to see if you can solve it, and then we'll get into the solution. You can pause the video if you need more time, but let's get into the solution. Now, one of the first things I recommend doing is establishing your data structures. So how is this binary search tree represented? Generally, we can represent a tree using a class for a node, and then there's going to be a value and a left node and then a right node. So just keep in mind that we're not coming up with a data structure for the entire tree, but rather it is just the data structure for each node that we're defining. And then we have a root node, which essentially represents the top of the binary search tree. So what is a decent algorithm for this? Well, if you think about it, for each node, we need to maintain the property that its value is less than some value and greater than some other value. And so if we were to take a look at this problem in more detail, like let's take a look at this tree. Well, we can take a look at the left side, and we know that whatever value here has to be less than 5. And on the right side, the value has to be greater than 5. And then once we get to this tree 7, then we know that any value left of that has to be Well, it still has to be greater than 5, but also has to be less than 7. And so when we check the value 2, we see that, well, it is not greater than 5, and we can return false. And similarly, if we were to have a branch on the right side here, like let's say this value was 8, then we would say that the restriction on this value has to be greater than 5 and greater than 7, or really just greater than 7. And so taking a look at this tree, you realize that as you traverse each subtree, you're going to want to pass down an upper bound and a lower bound for what those values can be between. And so let's try writing this down. Given the node n, it's considered a valid binary search tree if n.value is greater than some lower bound and n.value is less than some high bound, and you can say is valid binary search tree on n.left given a lower bound of low, and then the new upper bound is going to be n.value. And we have to also maintain that it's valid on the right side given the lower bound of n.value and then the upper bound of just the high value, whatever it currently is at. So these would all be ended together. Is valid then is going to be a recursive function, right? So we have is valid given the node, a low bound, and a high bound. And so then this would be the return value. And of course, there's also the base case where if not n, if it's empty, then just return true, because the empty node is still considered a valid binary search tree. And so this is pretty much what the solution looks like. What's the time space complexity? Well, in terms of the time complexity, we're just traversing through all of the nodes through a depth first search, and we go through all of them once. So in terms of time complexity, it is linear, or O of n time, with respect to the number of nodes that there are. And as far as the space complexity goes, well, let's imagine that we have a tree that is just a single branch all the way down. Then the space complexity is going to be proportional to the size of the recursive stack that we are building, right? Like you can just keep recursing down, and you start building up this function stack. So therefore, the space complexity is also linear in with regards to the size of the input. So the space complexity would also be O of n, linear time, linear space. That's the algorithm. I'll show you what this looks like in code. All right, so jumping into the code here, the first thing we want to do is define our data structure, which is the node, and then I'll come up with the constructor, which takes in a value, and then the left side, and then the right side. And then I'll just assign these to self.value equals val, self.left equals left, and self.right equals right. So that's pretty much the data structure, and then I'll come up with a test function for this. So I'll say, okay, node equals node 5, node.left equals node 4, and node.right equals node 7. So what we've created here is essentially a binary search tree that looks like 5, 4, and 7. And this is valid. And let me come up with a solution class. So we have class solution. And then there's the main function we have here, which is def is valid binary search tree given a node. And for now, we'll return false. So let me just run this now. Print solution dot is valid bst on node. If I were to run this, then we're expecting the value true. But right now we're getting false, of course. And so let me fill this out. The first thing is we're going to come up with a helper function for this in which we can pass in the low and high values as parameters. So let's define that. Def is valid bst helper given the node, the low value, and the high value. We'll return false for now. And then this function will return self.is valid bst helper given the node, and we'll pass in low and high values. So the low value will be a float of negative infinity, and then the high value will be infinite, okay? And so now we can fill out is valid bst helper. So we'll get the value equals no.val. So we need to check that if the value is greater than the low value and the value is less than the high value, and self.is valid bst helper on n.left given the valid range, which is from low to n.val, and self.is valid helper on the right subtree with the range restriction being on the current value to the high value. So let me put this on multiple lines so it's a little bit easier to read. And so if this condition is met, then we return true. Otherwise, we return false. And then there's one more thing we need to do here, which is a base case. If not n, then return true. So that should pretty much do. If I were to run this, then I'm getting the value true, which is correct. And I can also try this on another binary search tree. Like let's say it looks something like this, where you have a 2 on the bottom. So we'll say here node.right.left equals node 2. then we're expecting the value false for this. And so if I have to run this, then I'm getting the values true and false. So that looks like it works and pretty much wraps up this problem. Hope you enjoyed this one, and I'll see you in the next one.
Yeah, TechLead explained that perfectly. I don't have to tell you that. We will take a look at the next videos. The next video is ransom note. We will take a look here. I will show you exactly what awaits you here. Ransom notes, add two numbers as a linked list to some first and last indices of an element in a sorted array. So like you already see here, TechLead teaches you everything in regards to the tech interview that you have when you apply for a company like Facebook, Amazon, Google, and so on, and shows you exactly what those questions could be, what you have to know. And if you know that from someone that does the interviews, then you're prepared perfectly. And like you already see here, you have a lot of videos here. So you will know a lot of these things already, but some of these things might seem new to you, and that's definitely worth it to pass the interview process and get into one of those companies. Like you already see here, I will not show you everything right now, but all these important things are in the coding sessions. And then you also have a wrapping up section here where he basically wraps up everything that you have learned. You will learn everything that you need for the interview process. And if that's not enough, the coding part itself, you can also upgrade to the Tech Interview Pro for a comprehensive interview preparation workshop and a community for software engineers. You can take a look at the Bonusbomber video. I already made a video, not an interview, about this course where I show you how you can also prepare for the interview process and how TechLead teaches you that basic. Yeah, so like I already mentioned, you can get CoderPro via the link under my video, and you will additionally get my automation mastery worth $497 completely for free in my Bonusbomber package when you get CoderPro via the link under the video. Bonusbomber.com/CoderPro. It's the first link under the video that you see in the video description. Bonusbomber.com/CoderPro, and there you can also look at one of those videos that is inside the course. I wish you a lot of success with applying to those top tech companies. Bye bye.